On this paper, we present Navio, a visualization widget for summarizing, exploring, and navigating large multivariate datasets. Let's explain it by means of an example. Let's assume that, for instance, you want to visualize or explore the dataset that the Museum of Modern Art, the MoMA, in New York has released here in his GitHub page. It contains more than 100,000 records with many of the pieces that they have available online, and it contains many different attributes from that data. If you want to visualize this or explore that data, you could go and create interface like the one that the MoMA itself created. And with that, basically they use some of the traditional techniques for exploring datasets like this, that is to have a search box in which you can find specific things if you know what you're searching for. Or you can use different filters to, for instance, select different installations or I don't know, websites or videos or something like that. The problem with this type of interfaces is that even though they are very easy to use and people know them, is that you don't really get a good sense of how many of the pieces you're seeing. You have a number in here, but it's difficult to get a grasp on that. And on top of that, you don't get to see the full data. You don't see the errors on the data, you don't see the holes it has, the distributions, so it can actually get complicated. With Navio, what we do is that we first present the full length of the dataset, as you can see here with these bars. And we are seeing that we are looking at 133,000 records. Then on top of that, we can move our mouse and get in details on demand. Or we can start exploring interesting areas, like for instance this piece in here, that is showing us that for the height and the width, there are many pieces that didn't include any height or width. So those are kind of errors in the data. We can actually select exactly those areas or create a range selection, as you can see, and see the immediate details on the right. If you, for instance, want to perform a more specific query, you can come back in here and sort things by the ones that has an image. And by selecting those, you can see that only 64,000 pieces have an image. And you can start exploring and summarizing other things only from the ones that contain an image. Like, for instance, I can take a look at the nationality, and I can see that most of the pieces are from Americans. There's a lot of them from French people and also from German. And if I take a look at the distribution of gender, I can see that the big majority are, of course, of male. And then there's about 10 to 15% of female. You can also see that there are some other genders that get like weird values, like for instance these empty parentheses, or other ones that the museum has tagged with other different values like male, 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 that I guess are for multiple artists. You can start asking questions in here, like for instance, what happens if I only look at the ones in American nationality? And by that I can see that there are 29,000 images that have an image in the whole dataset and that are from Americans. Then I can sort by gender. Then I can see all the pieces by female, and then you can see that it's a good percentage of them are from women. But if I actually come back and then I look only at the ones from French artists by clicking here on the French bar, then I can see that there are 6,000, almost 7,000 pieces. And if I sort by gender, I can see a huge imbalance and only having mostly male pieces in the dataset. If I select the female ones, I can actually go and explore those and have different classifications and see which ones of those are drawings, or photographs, or different prints. And I can see the full length of my data query, perform complex queries as you can see in here, and get a clear sense of what I'm looking at in there. Navio also works very nicely with other complex datasets, like for instance networks. Here you're seeing a second example that we run analyzing the Colombian Senate patterns. You can see here 172,000 votings from the Colombian Senate, and you can see it contains almost 10 different attributes, including like the party that the senator belongs to, the type of initiative that they were looking for, or the topic that they were voting for. Let's use Navio to only look at the ones from the current period, that is between 2014 and 2018. And by doing that, what I'm doing is I'm creating a selection, and then the browser eats, and everything is being run on the browser, is recomputing the co-voting network that includes how many times each one of the senators has voted together. And as you can see in here, in the Colombian Senate, there's some different divisions depending on topics that they're voting. I'm going to select a specific corporation, in this case only the Senate, because this only contains the Cámara de Representantes, that it's a different instance in there. And in there you can see immediately that there's three groups in the Colombian Senate, ones that vote with the three parties, ones that vote with the two extremes, and then ones that only ones votes with the center, and the only ones that only votes with the center, but never with each other. I can also see things in more complicated queries, like for instance, if I want to see how the senators have voted for things like the armed conflict, as you can see in here, you can see that they have been pretty much consistent. Whereas if you go to other topics, like for instance, security and health or defense, you can start finding different patterns, and all of that while keeping track of what you're looking at. Finally, with Navio, we also released a tool called Navio Shipyard, because the idea is that you can include Navio as a widget on your application, or if you want, you can also use Shipyard to analyze your own data. So in this case, I'm going to use Shipyard to load the dataset of the BAST Mini Challenge 1 from 2007. And as you can see, it's very fast, has loaded 171,000 records that include the visits to a fictitious park. And then I can start immediately analyzing and seeing the distributions on how many of those entrances are through each one of the gates. I can see things by the different types of cars and start analyzing specific types of data. So with that, I hope you enjoy this demonstration of Navio. Thank you very much.